define electric flux. Is it a scalar or vector quantity? A point charge Q is at a distance of d by 2 directly above the center of a square of side D as shown in the figure. Use Gauss law to obtain the expression for the electric flux through the surface. Okay. And the B part of the question is, if the point charge is now moved to a distance d from the center of square and the side of the square is doubled, explain how the electric flux will be affected. First part of the question is define electric flux. We know that electric flux is the number of field lines passing through a surface normally. That is, electric flux through a given surface is defined as the dot product of electric field and area vector over that surface. Okay, that means alternatively we can say that is the electric flux of phi is equal to E vector into ds vector. It is a dot product. Okay, now also electric flux through a surface equal to the surface integral of the electric field over the surface. Okay, and it is a scalar quantity. Electric flux is a scalar quantity. Now, the given figure, here one plate is there. From the center, the charge Q they are going to create here from the distance d by 2. Okay, now I'm going to enclose this plate like a cube. If I'm going to enclose this plate like a cube, then we can see the diagram like this. This type of diagram we can see now. Right. And here then phi, there is electric flux is equal to, we know that that is charge enclosed divided by epsilon naught. According to the Gauss law, the electric flux is charge enclosed divided by epsilon naught. That is charge enclosed, it is Q divided by epsilon naught. From a single plate, now from the single plate, it is the electric flux is Q divided by epsilon naught. But now we have a 6 surfaces. That means a cube having a 6 surfaces. Then from one surface it is 1 by 6 into Q into epsilon naught. Through a one surface it is 1 by 6 into Q into epsilon naught. Then our equation is the electric flux through a square plate, that is Q divided by 6 into epsilon naught. This is the expression. And coming to the point B question here, if the charge is moved to a distance d and the side of the square is doubled, the Q will be constructed to have a side 2d, but the total charge enclosed in it will remain the same. Even the charge that is d by 2 will move to the d up to the d. When it is enclosed through a cube, the total electric flux it will remain the same as the total flux through the cube, and therefore the flux through the square will remain the same as before. That means it will not change the electric flux. It will remain as it is like before. Use Gauss law to derive the expression for the electric field E vector due to a straight uniformly charged infinite line of charge density lambda coulomb per meter. Okay. Now we'll derive the expression for first here. To define this one, to derive this one, we required one infinite y of charging. I just take here an infinite y. This blue color, this is the y, it is infinite y. Here also it is get continuous and here also it is get continuous. Okay. And for this infinite y, to derive an expression, I just enclosed this one in a surface, a cubical surface. It is very easy to derive the expression here. And the radius, this is the charge point R. charge point R here, and throughout the length, it is L, length is the L here. Flux through the curved cylindrical part of the surface is given by, that means the electric flux is equal to E into 2 pi RL, where 2 pi RL is the small area, surface area. And by applying the gas laws, that is electric flux is equal to Q enclosed divided by epsilon naught. The total charge enclosed here it is equal to linearly charged density into L, where the linearly charged density is nothing but the lambda into L. Therefore, the total flux F phi is equal to lambda L divided by epsilon naught. So this is the equation number 2. Now, using the equation number 1 and 2, we can say that total flux, that is E into 2 pi RL, is equal to lambda L divided by epsilon naught. And E is equal to lambda divided by this L will get cancelled. This L and this L will get cancelled. Then our expression is lambda divided by 2 pi epsilon naught into R. And vector notation, if I am going to define this in the vector notation, E vector is equal to lambda divided by 2 pi epsilon naught R into n cap. And if I take the second one here, draw the graph to show the variation of E electric flux with a perpendicular distance R from the line of charge. Now from the previous expression, that is E is equal to lambda divided by 2 pi epsilon naught R. That means E and R, if I am going to take here, that is E is inversely proportional to the R value, given radius value. That indicates when R value increases, the epsilon E value will be decreases. The E value will be decreases when R value is increases. This is the graph, variation in the graph. Next part is find the work done in bringing a charge Q from perpendicular distance R1 to R2, where R2 is greater than R1. Okay. Now, work done in moving the charge Q through a small displacement dr. Considering here a small displacement in this line, a small displacement, I will take this is R1 point and the remaining is the R2 point I can take here. In between here I am going to take a small displacement, that is dr. I am going to derive the expression for the dr first. Then I am going to integration with R2 to R1 I will do here. Then dw, that is a work, small work that is equal to F into dr, that means force into displacement in vector. This is a F vector into dr vector. And dw is equal to F force is equal to Q into E vector into dr vector. It's nothing but Q into E into dr cos 0. Because the cylindrical surfaces here, whatever the charge it is there, the cos theta, that means it is outside, whatever charge is there, this is outside, then the cos is 0. If it is, if I am going, this is the curved surface, so the cos theta will become 0. If I am going to take over the plane surface over here, if I am going to take, then it will becomes the cos 90 degree. But since they are asking the curved surface, here the cos theta, that theta value becomes 0. Okay. Then dw is equal to Q into this E dr cos theta, that is a lambda divided by 2 pi epsilon naught into dr. Now, the R2 to R1, where R2 is greater than R1, then I go to integrate this one with respect to R2 to R1. Then work done, the total net work done is equal to W is equal to lambda into Q divided by 2 pi epsilon naught into logarithm to the base E R2 minus logarithm to the base E R1. This is the total work done in moving the charge Q through a small displacement. Small displacement is this one. Then the total displacement from R2 to R1 is, this is the expression.